In this video, we will see how we can use the log and exponential functions concept to solve problems. Just to recap, the log of a number tells us to what power should you raise a particular number to get that number. So for example, as we had seen, the log of 10 or log of 100 is 2. That means that we have to raise 10 to the power 2 to get to 100. In other words, log of 10 is just 1. It means we have to raise 10 to the power 1 to get 10. Similarly, if we look at the natural log, then the natural log of e is asking us to what power do we raise e to get e, and then the answer is just 1. Now suppose my number that I'm interested in is ex. So the question is asking to what power should we raise e to get x, and well, the answer then is simply x. So if we raise e to the power x, we get ex. So we will kind of use the interplay of these to figure out how to use these to solve some application questions. So this problem says that an online program at a certain university started with 560 students, and that it has grown to the level where it has reached 1,750 students. And we're also given the time frame. What we're not told is at what rate did this program grow. So we have to basically find a function or an exponential function that's going to give enrollment as a function of time. Now we know that there is an exponential growth going on. The question says exponential function. Just to recap our discussion of compound and interest. So we had said that the amount after t years is simply what you start with plus 1 plus r t. Right? So we can now translate this formula or this exponential growth function into the context of our problem at hand. So we are told that the initial amount, or P naught for initial amount, was 560. We're told that the growth that resulted in happened so that in the end we had 1,750 students, and that this growth was over a period of 4 years. So now let's cast this into our notation. What we get is 1750 equals 560 times 1 plus r to the 4th power. Now we can kind of start simplifying this already. What we get then is 1 plus r to the 4th power by itself equals 1750 divided by 560. Then we can plug this in the calculator and see that this is 3.125. So we get 3.125. So this boils down to saying that 1 plus r to the 4th power equals 3.125. Now if we just solve it directly, it can get a little convoluted. So we will use the notion of log and exponential functions and how we can move from one to the other. And we'll take the log on both sides here. We take the natural log of our left-hand side, we get 1 plus r to the 4th power. I'm going to put all of this in parentheses, equals the natural log of 3.125. And then simplifying our left-hand side, what we get is that 4 times the natural log of 1 plus r equals the natural log of 3.125. Or the natural log of 1 plus r equals the natural log of 3.125, and we divide this by 4. So we can again now simplify what our right-hand side expression is. 0.2848. So what we get is that the natural log of 1 plus r equals 0.2848. Now we will go back and use our idea of exponential and log functions. So just like we said that if we take the log of ex, we get x, we can also work on the opposite direction, and we can say that the exponent of log of x is simply x. Right, so these two will work in both directions. Essentially, log is the opposite to the exponential function. So if we take the log of e, we get the exponent of e back. If we take the exponent of log of x, we will get x back. So think of log and exponential functions kind of canceling each other out. So now I can exponentiate both sides. So when we exponentiate the left side, we simply get 1 plus r. When we exponentiate the right side, we will get e to the power 0.2848. And then let's see what this is equal to. And this equals 1.329. Okay. So what we get is that 1 plus r equals 1.329. So if we were precise, then our r is actually 32.9%. So this gives us the expression for enrollment at any time t equals our initial enrollment plus 1 plus r to the power of t. Now what are these numbers? We said that we initially started with, as per the statement of the problem, 560 students. And then our 1 plus r was found out to be 1.329. So we can say it's 560 times 1.329 to whatever the power of t is. So this will now help us find the enrollment after any period in time. If we want to find enrollment after 10 years, we can simply plug in 10 for t. If we want to find enrollment after 15 years, plug in 15 for t. So this is called the general exponential function, which is capturing the growth given by our case at hand. Hope this clarifies how to solve log and exponential functions. Thank you.